sklearn, features election, SelectFwe. Description. SelectFwe is a feature selection method that uses a f-test to rank features by their statistical significance. It then selects the features whose p-values are below a user-specified threshold using the f-test. The f-test measures the variance between the means of two groups divided by the variance within each group. This method is useful for selecting features that are most likely to be predictive of the target variable, while also controlling the family-wise error rate FWER at a given level. Inputs. sklearnfeatureselectionSelectFwe, a function that takes two arrays x, y and returns a pair scores. P-values where scores is a 1D array of scores for each feature and p-values is a 1D array of corresponding p-values. Alpha, the alpha level for the f-test, corresponding to the desired family-wise error rate FWER. A higher alpha means a higher chance of selecting irrelevant features. Outputs. Selected features, a Boolean array of the same length as the number of features. True indicates that the feature is selected. False indicates it is not selected. Features ranking a 1D array of feature indices. Sorted in decreasing order of f-statistic. Steps. Calculate the f-statistic and p-value for each feature using the input sklearnfeatureselectionSelectFwe. Rank the features in decreasing order of the f-statistic. Use the specified alpha level to determine the p-value threshold. Select all features with p-values below the threshold. Metrics. F-statistic measures the variance between the means of two groups divided by the variance within each group. Higher values indicate more significant features. P-value represents the probability of observing the given data if there is no relationship between the feature and the target variable. Lower values suggest a stronger association. Visualization plots. Feature importance plot. This plot can be created using the feature ranking and f-statistics to visualize the relative importance of each feature. Feature selection heat map. This can be used to visualize the correlation between features and a target variable, with different colors representing the strength of correlation. Fine-tune parameters. sklearnfeatureselectionSelectFwe adjusts the score function based on the type of data and the relationship you are looking for, e.g., using ANOVA for categorical target or a regression model for continuous target. Alpha. Increasing alpha allows for more features to be selected, but increases the chance of false positives. Uncertainty methods. Permutation testing. This can be used to assess the stability of the feature selection results by randomly shuffling the target variable and rerunning the feature selection process. Bootstrap aggregating can be used to estimate the uncertainty of the feature selection process by resampling the data with replacement and repeating the feature selection process multiple times. Challenges and fixes. Challenge 1. Overfitting due to choosing too many features. Sample use case. Using a very low alpha value, e.g., 0.01 for a dataset with a large number of features. Selecting many features that may not be truly important, and leading to overfitting. Fixes. Increase the alpha value to reduce the number of features selected. Use cross-validation to assess the performance of the model with different numbers of selected features. Apply regularization techniques to the model to prevent overfitting. Challenge 2. Underfitting due to choosing too few features. Sample use case. Using a very high alpha value, e.g., 0.5 for a dataset with a small number of features. Selecting too few features to capture the underlying relationships, and leading to underfitting. Fixes. Decrease the alpha value to increase the number of features selected. Explore using other feature selection methods that are less restrictive, such as SelectK best, a recursive feature elimination. Consider adding more features to the dataset. Challenge 3. Selecting features that are highly correlated with each other. Sample use case using SelectFwe on a dataset with multiple features that are highly correlated with each other. The method may select only one of the correlated features while discarding the others, leading to an incomplete representation of the underlying relationships. Fixes. Use a different feature selection method that explicitly considers feature correlations, such as select from model with AL1 penalty. Apply dimensionality reduction techniques, such as PCA, to reduce the number of features while preserving the most important information. Manually analyze the correlated features and select only a subset that is most relevant. Challenge 4. Selecting features that are not relevant to the target variable. Sample use case when the dataset contains features that are correlated with the target variable, but are not truly causal. This can happen if there is a confounding variable that affects both the feature and the target. Fixes. Conduct domain-specific analysis to identify and remove irrelevant features. Use causal inference techniques to identify features that have a causal relationship with a target variable. Employ feature selection methods that consider the causal relationships between features and a target variable.